Welcome back friends. Welcome back to another video session from this channel. So in this video session, we are going to study regarding the elongation phase of the translation in case of prokaryotes. So once when the 70S pre-initiation complex, when it has successfully organized during the initiation phase, now the 70S pre-initiation complex, it is ready to participate in the elongation phase of the translation. And here, in order to organize the elongation phase of the translation, the specific mechanism or the specific process, it takes the advantage of certain elongation factors. So what are the certain elongation factors which govern the elongation phase here? EFTU, EFTS and EFG. Is it okay? So let me write it here. EFTU, EFTS and the other one is EFG. Is it okay? So by taking the advantage of these elongation factors, the elongation phase of the translation in case of prokaryotes, it is successfully organized. So at the very beginning of the elongation phase of the translation in case of prokaryotes, the specific EFTU, it comes into the picture. So before studying the entire mechanism or the entire process of the elongation phase of translation in prokaryotes, at first let us have a look on the activity of these elongation factors so that easily you can understand. Is it okay? So what is EFTU here? EFTU, it is the specific elongation factor which plays a prominent role for the successful recruitment of the amino acid tRNA to the A site of the ribosome. Is it okay? Then what is EFTS here? EFTS, it is an guanine nucleotide exchange factor, or it is simply termed as GEF. And EFG, it is the specific elongation factor which plays a prominent role for organizing the translocation of mRNA. So these are the three elongation factors which play a prominent role for organizing the elongation phase here. So at the very beginning of the elongation phase of translation, the specific EFTU elongation factor, it comes into the picture. So for the successful recruitment of the amino acid tRNA to the A site of the ribosome, is it okay? So for the successful recruitment of the amino acid tRNA to the A site of the ribosome, EFTU elongation factor, it is required. But the specific EFTU, it remains in active conformation and it is capable to recruit the amino acid tRNA to the A site of the ribosome only when it is in association with GTP. So let me write it here. EFTU, when it is in association with GTP, it remains in active conformation. Is it okay? So once when the specific EFTU, when it remains in active conformation, now the specific EFTU, it is capable to recruit the amino acid tRNA with its encoding amino acid to the A site of the ribosome. Now in between, once when the amino acid tRNA with its encoding amino acid, when it has successfully recruited to the A site of the ribosome, now in between the initiated tRNA encoding amino acid and the amino acid tRNA encoding amino acid, peptide bond formation takes place. Is it clear? So let me write it here. So this is the first peptide bond formation, right? And here, in order to organize the peptide bond formation in between these two amino acids, a specific enzyme known as peptidyl transferase, it comes into the picture. So the specific peptidyl transferase activity, it is a part of 23S rRNA which is embedded in the large subunit of the prokaryotic ribosome. So by taking the advantage of 23S rRNA, here the peptide bond formation, it takes place in between the initiated tRNA encoding amino acid and the amino acid tRNA encoding amino acid. So for your better understanding, let me present you the chemical reaction which takes place in between these two amino acids. Is it okay? So let me present it here. The peptide bond formation in between these two amino acids, right? So this is the formulated amino acid. Formulated amino acid, right? And here it is the amino acid tRNA encoding amino acid. Now here in between these two amino acids the peptide bond formation takes place. So if we look at here the specific oxygen atom which is a part of the carboxyl group, is it okay for you? The specific oxygen atom which is a part of the carboxyl group, when it undergoes nucleophilic attack or nucleophilic cleavage, now here the peptide bond formation it takes place in between these two amino acids. So here the peptide bond formation it is organized by peptidyl transferase. So let me present it here. So if we look at here, the specific oxygen atom which is a part of the carboxyl group, when it had undergone nucleophilic attack or nucleophilic cleavage, now the specific oxygen atom it is removed and it is replaced by the nitrogen atom which is a part of the amino group of another amino acid. So if you look at here, easily you can understand. Here the oxygen atom it is removed and it is replaced by nitrogen atom which is a part of the amino group of another amino acid. So in between these two amino acids the peptide bond formation has took place, and here in order to organize the peptide bond formation a specific enzyme known as peptidyl transferase it comes into the picture. So here the specific peptidyl transferase activity it is a part of 23S rRNA which is embedded in the large subunit of the prokaryotic ribosome. Is it okay? So once when the peptide bond formation when it has successfully organized in between these two amino acids, now the specific initiated tRNA which has recruited to the P site it gets successfully translocated from the P site to the E site. Is it okay? So let me present it here. So this is nothing but the initiated tRNA, right? So when the specific initiated tRNA, when it had undergone translocation from the P site to the E site, now the P site of the ribosome it remains free. Now the P site of the ribosome it gets occupied by the amino acid tRNA which has initially recruited to the A site. So once when the amino acid tRNA when it has got successfully translocated from the A site to the P site, now the A site of the ribosome it remains free. And here in order to organize the translocation of mRNA, the elongation phase of the translation it takes the advantage of a specialized elongation factor which is nothing but EFG. So what is EFG here? EFG it is the specialized elongation factor which is responsible for organizing the translocation of mRNA. But the specific EFG, likewise EFTU, it takes the advantage of one molecule of GTP. So by taking the advantage of one molecule of GTP, EFG it is capable to organize the translocation of mRNA. So let me present it here. One molecule of GTP, right? So by taking the advantage of EFG, the translocation of mRNA, it is successfully organized here. Now here my question is, for organizing one peptide bond, the elongation phase of the translation or the translation mechanism, it takes the advantage of how many molecules of ATP and how many molecules of GTP. So the answer to this question is very simple. For organizing one peptide bond formation, The specific translation mechanism or the translation process, it takes the advantage of one molecule of ATP and two molecules of GTP. Is it okay? So once when the translocation of mRNA, when it has successfully organized here, now the A site of the ribosome, it remains free, right? Now again, the A site of the ribosome, it gets occupied by the amino acid tRNA with its encoding amino acid. But for the successful recruitment of the amino acid tRNA to the A site of the ribosome, a specific elongation factor known as EFTU is required. But the specific EFTU, it is under inactive conformation. Is it okay? Because the specific EFTU, it has successfully recruited the amino acid tRNA with its encoding amino acid to the A site of the ribosome in the previous peptide bond formation. Under such condition, EFTU, which is in association with GTP, it undergoes hydrolysis and it remains in inactive conformation. Inactive EFTU, it is unable to recruit the amino acid tRNA to the A site of the ribosome. So in order to overcome the problem, EFTU, which is in association with GDP, it gets associated with a specialized elongation factor, which is nothing but EFTS. So once when the EFTU GDP, when it gets associated with EFTS, now again the specific EFTU, it acquires its GTP conformation. Is it okay? So let me present it here. EFTU, which is in association with GDP, it gets associated with EFTS, right? EFTS, which is an guanine nucleotide exchange factor. EFTU, which is in association with GDP, it gets associated with EFTS, which is an guanine nucleotide exchange factor. So once when the EFTU GDP, when it is in association with EFTS, again the specific EFTU, it acquires its active conformation. So once when the EFTU, when it acquires its GTP conformation or its active conformation, again the specific EFTU, it is capable to recruit the amino acid tRNA to the A site of the ribosome, and again it leads to the activation of peptide bond formation in between the peptidyl tRNA encoding amino acid and the amino acid tRNA encoding amino acid. Is it okay? So let me present it here. Peptide bond formation, again it took place here, right? So these series of sequence of events, they will continue until the small subunit of the ribosome, it is about to recognize or it is about to reach the stop codon or the termination codon. So once when the small subunit of the ribosome, when it is about to recognize or when it is about to reach the stop codon or the termination codon, under such condition, the polypeptide chain synthesis, which has took place so accurately during the elongation phase, it gets successfully inhibited. So this is regarding the elongation phase of the translation in case of prokaryotes. I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day. Thank you.